Good morning, students. Welcome to Bindu Dhadwal chemistry lessons. Today we'll talk about hydrogen peroxide, its importance as a chemical, its methods of preparation, its physical state, chemical properties, structure, storage, and uses. We will also talk about heavy water and dihydrogen as a fuel. We will also talk about hydrogen economy. So let's begin the video. First is hydrogen peroxide. It is a very important chemical and is used for pollution control of effluents that are produced in domestic and industrial level, that are produced at domestic and industrial level. So hydrogen peroxide can be prepared by number one, acidifying barium peroxide and removing excess water by evaporation under reduced pressure. So barium peroxide, when treated with sulfuric acid, will give barium sulfate and hydrogen peroxide along with water. Peroxodisulfate obtained by electrolytic oxidation of acidified sulfate solutions at high current density on hydrolysis will also yield hydrogen peroxide. So, we carry out electrolysis of hydrogen sulfate ions to form peroxodisulfate. On hydrolysis, it is going to form hydrogen peroxide and hydrogen sulfate will be given off as byproduct. Similarly, potassium persulfate, when reacted with heavy water, deuterium oxide will produce potassium deuterosulfate and deuteroperoxide. This is a laboratory method of preparation of deuteroperoxide. Deuterium is an isotope of hydrogen having atomic number 2. Laboratory having mass number 2. Atomic number is 1. Laboratory preparation of deuterium peroxide. Industrially, hydrogen peroxide is prepared by auto-oxidation of 2-alkyl anthraquinone. So 2-ethyl anthraquinone, when oxidized with oxygen of air in presence of hydrogen and palladium as catalyst, will form it's the oxidized product of 2-ethyl anthraquinone, which is quinone, and along with that hydrogen peroxide is produced. This hydrogen peroxide is 1%. It's extracted with water and concentrated to about 30% by mass by distillation under a reduced pressure. Then further concentration is done by careful distillation under low pressure and we get about 85% hydrogen peroxide. Then we can freeze out the remaining water to obtain pure hydrogen peroxide. Physical state: in the pure state, hydrogen peroxide is almost colorless, a very pale blue colored liquid. It's miscible with water in all proportions and forms a hydrate, hydrogen peroxide monohydrate, where melting point is about 221 Kelvin. And a 30% solution is marketed as 100 volume hydrogen peroxide. This means that 1 milliliter of hydrogen peroxide, 1 milliliter of 30% hydrogen peroxide will give 100 milliliter of oxygen at STP. Commercially marketed sample is 10 volume, which means that the sample contains 3% hydrogen peroxide. We can find out the strength of hydrogen peroxide from the volume labeling. For example, if we have to calculate the strength of 10 volume solution of hydrogen peroxide, we'll write down the equation, which is 2 hydrogen peroxide will decompose to give oxygen and water. This is balanced equation. From the equation, we come to know that 2 moles of hydrogen peroxide give 1 mole of oxygen gas. So at STP, 1 mole will occupy 22.7 liters of oxygen. So that means 22.7 liters of oxygen are given off at STP by 2 moles means 68 grams of hydrogen peroxide. So using unitary method, 22.7 liters are produced by 68 grams. So 1 liter will be produced by 68 upon 22.7, and 10 liter of oxygen at STP will be produced by 68 upon 22.7 into 10. This comes out to be approximately 30 grams. So that means 1 liter strength of hydrogen peroxide in 10 volume hydrogen peroxide is 30 grams per liter. That means per 100 grams it's 3. So this is 3% hydrogen peroxide. This is the strength. Physical properties of hydrogen peroxide: melting point is 272.4 Kelvin, boiling point 423. Vapor boiling point cannot be calculated experimentally. We just draw the graph and extrapolate it to find the boiling point, the point where the vapor pressure of water will meet the atmospheric pressure. The temperature at which it meets the atmospheric pressure will be the boiling point. Vapor pressure is 1.9 millimeter mercury at 298 Kelvin. Solid hydrogen peroxide has density of 1.64 grams per centimeter cube. Liquid has density of 1.44 grams per centimeter cube. Viscosity is 1.25 centipoise. Dielectric constant at 298 Kelvin is 70.7 coulomb square per Newton meter square. And electrical conductivity at 298 Kelvin, 5.1 into 10 raised to power minus 8 ohm inverse centimeter inverse. Structure of hydrogen peroxide: it has a non-planar structure. Means structure is dihedral. Dihedral means that there are two planes in which the hydrogen peroxide will exist. Just like this register here is showing, these are the two planes, one which is at an angle to the plane which is lying down on the table. So the angle between the two faces is called dihedral angle. So these the molecular dimensions are different in gaseous phase and in solid phase. In gaseous phase, the dihedral angle between the two planes is 111.5 degree, whereas it's less in the solid phase. Then this hydrogen peroxide molecule, the bond length of oxygen is 147.5 picometer in gaseous phase and less 145.9 picometer in solid phase. Oxygen hydrogen bond length is 95 picometer. It's more, 98.8 picometer. The bond angle is 94.8 degrees. The bond angle is more, 101.9 degrees. So these are the different structures of gaseous phase hydrogen peroxide and solid phase. Chemical properties. Hydrogen peroxide can act as an oxidizing agent as well as a reducing agent in acidic medium as well as alkaline medium. So let's take examples of oxidizing action of hydrogen peroxide in acidic medium. So ferrous ions are oxidized to ferric ions by hydrogen peroxide in acidic medium. The reaction is ferrous plus hydrogen ions, hydrogen peroxide will form ferric plus water. Similarly, hydrogen peroxide will oxidize lead sulfide to lead sulfate. It will oxidize ferrous to ferric and lead sulfide to lead sulfate in acidic medium. Then it can also act as a reducing agent. It will reduce permanganate to manganese dipositive ions and hypochlorous acid to chloride ions. So it's acting as a reducing agent in acidic medium. Then it can act as an oxidizing agent in basic medium. For example, it will oxidize ferrous ions to ferric in basic medium. It can also oxidize manganese dipositive ions to manganese tetrapositive ions in alkaline or basic medium. It can also act as a reducing agent in basic medium. So it will reduce iodine to iodide ions. So it's acting as a reducing agent in presence of hydroxide ions. Oxygen is also produced. Similarly, it can reduce permanganate ions to manganese dioxide. So from +7 to +4, this is reduction, decrease in oxidation state. So hydrogen peroxide reduces permanganate ions to manganese dioxide, so causing reduction, so acting as a reducing agent. Hydrogen peroxide decomposes slowly on exposure to light. So we have to be careful while storing it. It will decompose in presence of metal surfaces or traces of alkali in glass container. So these components act as a catalyst and speeden up this reaction. So in order to avoid decomposition of hydrogen peroxide, we must store it in wax-lined glass containers or plastic vessels, and the bottles should be colored so that light is avoided, and we can also put urea in it, which acts as a stabilizer. We should always keep it away from dust because dust can induce explosive decomposition of compound. Uses of hydrogen peroxide. Its widespread use has led to widespread increase in the production of hydrogen peroxide. It is used as a hair bleach, as a mild disinfectant, and as an antiseptic under the name perhydrol. Then it is used to manufacture chemicals like sodium perborate and percarbonate. These are used in high-grade detergents. Then hydroquinone, tartaric acid, some food products, pharmaceuticals like cephalosporin can be made from it. It's employed in the industries as bleaching agents for bleaching textile, paper pulp, leather, fats, etc. Nowadays, it's also used in environmental chemistry, green chemistry, that is to reduce pollution. For example, pollution control treatment of domestic and industrial effluents. Hydrogen peroxide is used in oxidation of cyanides, in restoration of aerobic conditions of sewage waste, etc. Hydrogen peroxide is used so that the pollution can be biologically removed. Heavy water. So the isotope of hydrogen, deuterium, its compound is known as heavy water. Its molecular mass is 20 as compared to 18 of normal water. This deuterium oxide or heavy water is used as a moderator in nuclear reactors and in exchange reactions for study of reaction mechanism. We can know how a reaction occurs with the help of this deuterium oxide. It is prepared by exhaustive electrolysis of water. We will add water in a tank and we will continuously carry out its electrolysis. Hydrogen is produced at one end and oxygen is produced at other end. The water keeps on disintegrating into hydrogen and oxygen. The water which is left behind after exhaustive electrolysis will be heavy water. It's said that if we will electrolyze about 1,000 kilos of water, 1 kg of heavy water will be produced. As a byproduct in some fertilizer industries also, we get heavy water. Heavy water is used in preparation of other deuterium compounds also. For example, we can prepare deuteroacetylene, we can prepare deuterosulfuric acid and deuteromethane and from heavy water. Dihydrogen as a fuel. Now, we are studying chapter hydrogen. Hydrogen is a very important fuel. We can just compare it with other fuels per mole, per gram and per liter. So you see that per gram hydrogen, 1 gram of hydrogen gives 143 kilojoules of energy, which is greater than other fuels like LPG, methane and octane. Per gram it's 47, but per mole the value for other fuels is higher. On mass to mass basis, hydrogen can release more energy than petrol, about 3 times. Pollution will also be less using hydrogen as a fuel. So only pollutant can be oxides of nitrogen, because nitrogen almost comes as mixed with the hydrogen gas, and we can reduce this pollution also by injecting a small amount of water in the cylinder to lower the temperature, so that reaction between nitrogen and oxygen does not occur and this pollutant is not formed. The limitations, but mass of a cylinder containing hydrogen is very much about 30 times more heavy than a tank of petrol containing the same energy as this much of hydrogen. Then also hydrogen, to be converted to liquid state, we have to cool it to 20 Kelvin. So this requires very expensive insulated tanks. So that's also a limitation in using hydrogen as a fuel. So the alloys, metal alloys such as sodium, nickel 5, titanium, titanium hydride, magnesium, magnesium hydride have to be used to store hydrogen in small quantities. So these limitations, its mass, its heaviness, these limitations have prompted researchers to search for alternative technique to use hydrogen. Once we get these techniques, the problem for energy deficiency can be solved to a great extent. So in this view, hydrogen economy is an alternative. And the basic principle of hydrogen economy is we need to know techniques to transport and store energy in form of liquid or gaseous hydrogen. And advantages are that energy is transmitted in the form of dihydrogen and not as electrical power. For running automobiles, in India in 2005 October, we first time used hydrogen as a fuel in a small amount, 5%, mixed with CNG. And it was used for four-wheelers. And it is planned that this percentage would be gradually increased to reach the optimum level. And nowadays, hydrogen is also used in fuel cells for generation of electric power. And it is expected that economically viable and safe sources of hydrogen will be identified in years to come for its usage as a common source of energy. So that's all in today's video. This brings us to the end of chapter hydrogen. If you like the video, please do share and subscribe. Thank you. Have a nice day.